Hey everyone! Today we're going to be evaluating a limit as x approaches infinity. So the way that you would solve these types of limits is actually very special. There is a new method that you're going to use to solve such problems, and it is not the same method that you would use to solve every other type of limit. So let me show you how you can do that. Let's say you are given this problem, okay? Evaluate the limit. Limit as x approaches infinity of 2x to the power 4 plus x squared plus 2 over x to the power 4 plus 1, right? So the first step that you want to do for any of these types of limits is look at the highest power of x in the denominator. In this case, the highest power, let me actually write that down. So highest power in the denominator. Okay, so when you look at the highest power of x in the denominator, in this case, it will be x to the power 4, right? Because there's no other greater term of x in the denominator. And you want to focus on the denominator. Always remember, it's just the denominator now. So what are you going to do now? You know that the highest power of the denominator is x to the power 4, right? So when evaluating such limits, you actually want to divide both the numerator and denominator by the highest power of the denominator. So let me show you what that looks like. When you do this, you're just going to multiply the numerator and the denominator by 1 over x to the power 4. You're going to multiply both the numerator and denominator by 1 over x to the power 4. This is the same thing as dividing both the numerator and denominator by 1. This is the same thing as dividing the numerator and denominator by x to the power 4. So when you do this, you're going to get limit as x approaches infinity of, 2x to the power 4 over x to the power 4, right? That's just 2, plus x squared over x to the power 4, that's 1 over x squared, plus 2 over x to the power 4, right? So that's just 2 over x to the power 4. And then in the denominator, x to the power 4 over x to the power 4 is just 1. And 1 over x to the power 4 is just 1 over x to the power 4. Let me put brackets around this. It's getting a little slanted. So now we have used this method that we always use for limits that approach infinity, right? We have applied that method. So now this makes it so much easier to solve. Let me tell you why. One thing you should always remember in such problems is that whenever there's a limit that approaches infinity and there are values or there are expressions in here that are like such terms that are 1 over x squared or 2 over x to the power 4 or 1 over x to the power 4, right? Basically, any terms where there's a constant number over a power of x, remember it must be constant in the numerator and a power of x in the denominator. If there is such a term and the limit is approaching infinity, then you can say that when this limit is evaluated, these terms are going to become 0. Now, let me explain why. Let's take this case of 1 over x squared, right? From here, okay? I'm taking this one. Let's just look at 1 for now. So when I evaluate just this as x approaches infinity, what are we going to get? We're going to get 0. But why? Let me tell you why. When x equals 1, this is going to be equal to 1. When x equals 2, this is going to be equal to 1/4, right? When x equals 3, this is going to be equal to 1/9. But what if we have x equals 5? It's going to be 1/25, right? What if we have x equals 10? We're going to have 1/100th. So do you see a pattern here? As the x value increases, our y value gets smaller and smaller. It went from 1 to 1/4 to 1/9 to 1/25 to 1/100. And as you can see, as x gets larger and larger, this fraction is only going to keep getting smaller. But the reason why this means that it approaches 0 is because it's never going to become negative. That's because in the denominator there's an x squared, so this term is always going to be positive. So if this term is always going to be positive, but is always going to get smaller and smaller, that must mean that it is approaching 0. This is why for any term that there is a constant value over a power of x in the denominator, that limit as x approaches infinity will equal 0. So keeping this in mind, when we actually evaluate this limit, we're going to get limit as x approaches infinity of this whole expression, right? And that's going to be 2 plus 0 using this method above, plus 0, right? Because a 2 over x to the power 4 is also a constant value over a power of x, so that will also evaluate to 0. And then all over 1 plus 0 again, because 1 over x to the power 4, right? That's a constant over a power of x. So this is going to simplify to 2 over 1, which is equal to 2. And that is our final answer.